chapter 3, section 3, sorry. So I'm going right to 5.5, which is the last one. So your homework for what I'm going to lecture on today is going to be 1 through 38, every third one, such as 1, 4, 7, 10, etc., correct? Make sure we get that all clear. So, let's take the function y equals sine of x. So I sketched out some of it. I didn't really put any units on my x and y axis. I guess I better do that. That's 1, and that's negative 1. And so this is at 2 pi, this is at pi, this is pi over 2, this is 3 pi over 2. What is this? This is 5 pi over 2, this is 3 pi, this is negative pi over 2, and this is negative pi. There. And of course it's 0. There, put some units on that. And so from this graph, I'm going to do it pictorially, to find the solutions. I'm now going to solve this. Find the solutions to sine of x equals 1/2. So my y output is 1/2. What x's will make this true? Well, here's my y-axis. So if this is 1, then 1/2 is in here, right? Isn't on that line? All of those, right? And so I need to find the intersection. So it's at this x, and this x, and this x, and this x forever, in both directions, positive and negative, right? In fact, sine is, the output is positive in what 2 quadrants? In quadrant what and what? 1 and 2, right? In quadrants 1 and 2. Because there's 3 and 4. So in quadrant 1, so let me write down sine of x equals 1/2, right? It's positive. What x is in quadrant 1? What x's make it true? Now all I did is I extracted out the x to answer only the x. What x would make that true up here? What would that be in there in that unit circle? I'll let you tell me. On the unit circle, quadrant 1, what angle measurement, and let's do radians, obviously, will give me 1/2. Pi over 6, thank you for answering. So this is pi over 6, but it happens again, and it happens again, and again, and again, and again. So it's pi over 6 plus every full rotation, right? Here, and every time I land on this terminal side. Every time, whether I go positive or negative, every time I land on that terminal side, which is the reference angle of pi over 6 for quadrant 1, right? Then I will get a solution. And I'm sorry, let me put the word find all the solutions. There's all the solutions for quadrant 1. At pi over 6 and every rotation. What does the n mean? N means I use integers. N is for integers. -2, -1, 0, 1, 2, 3, etc. N is for all integers. And you have to claim that in your answer. You have to state what n is. So when n is 0, this goes away. So one solution is pi over 6. When n is 1, that means 2 pi. 2 pi plus pi over 6, well, that makes sense at 2 pi plus pi over 6, right? So that would be 13 pi over 6? Yeah. So if I'm supposed to list off my answers, I could start with a positive 1, pi over 6, then 13 pi over 6, then I add another 2 pi in, which is 12, right? So what would that be? 12, 24, 25, pi over 6, etc. Going backwards, what would that be in negative, right? So this is pi over 6 this way, and wonder what it is this way. That would be negative 11 pi over 6, negative, instead of 24, 23 pi over 6, etc., right? But if I want to find all of them, I can't list them all out. I leave it like here generically. It's this terminal side and every rotation, positive and negative. N is for integers, for all integers, -3, -2, 0, 1, 2, 3, 4, etc. But I can't write the list. I'm just giving you a suggested list of what that would be like. But you also told me quadrant 2. So in quadrant 2, over here, what angle measurement will give me, the sine of it will give me 1/2 in radians? 5 pi over 6 plus every rotation. So the answer is this and this.
You have to put an n is for all integers?
Yes, you have to tell me what n means.
Oh.
Because I want you to tell me all the possible solutions. All the possible solutions are here. And how do I get all of them? Because it's going to keep happening forever. I'm going to have a multitude of answers. An infinite number of answers. Comes from quadrant 1 like this. It's going to be right here, right here, right here, right here. But also as it's coming down at this one here, which is 5 pi over 6. So this is how I state it. At all of these possible x values, so I would have to add more to my list. 5 pi over 6 would land in here, plus another rotation of 12 pi over 6. That would land in here, etc. Did I make any sense here? No, I got to know. No, if it's no, no is good. Is it no? That makes sense? Okay. So first off, now I got to solve, okay? I'm going to first off find all the possible solutions to this function. Well, I've graphed it out. I'm going to do it pictorially. And I'm going to take sine of x equals 1/2. That's my y output. Here's my y output. I sketched a line of 1/2 and find out where this graph will intersect it. It's at this point, this point, this point, this point. And every time it goes up and down, right, it's going to happen here. So which x values have a y output of 1/2? Which x values have a y output of 1/2? Then so it'd be at this one, and 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 this one. Oh, I notice that's a pattern. It always seems to be right here and here, and here and here, and here and here, and here and here. Interesting. Well, I think about the unit circle, it would be for quadrant 1, which this is quadrant 1 from 0 to pi over 2. Well, that would be pi over 6. And so every time I land on here, whatever angle it is, the sine of that would be 1/2. Well, between pi over 2 and pi is quadrant 2, which we already know that. We know sine of angle measurement is always positive for quadrant 2 for sine. And so we asked which specific one it is. That's for pi over 6 and every complete rotation. That's how I get all of them, is by making this notation here. So let's try one now, without drawing pretty pictures. We're going to be learning, starting today and over the next few days, of doing 5.5 techniques to solve a trig equation. A trig equation. Equal sign, equation, trigonometry. Solve it. Solve it for what? For x. The technique we're going to learn today, only one technique. It is isolate the trig function. And then we have our first problem there. 5 times sine of x equals 3 times sine of x plus square root of 3. We need to solve for x. What x will make that statement true? In this one, I'm supposed to be finding all of the solutions. I'm going to scoot this up. Right there. So I'm going to use that technique that is suggested to me to isolate the trig function. I notice the trig function in this one happens to be the same. It's sine of x. So I want to isolate that. So to isolate that, like you do y's, like you get x's on one side and y's on the other, whatever, I want to get it all by itself. So I have 1 on either side. I might as well take this one over here, right? So it's 5 sine of x minus 3 sine of x equals 3 sine of x minus 3 sine of x plus square root of 3. I just very slow and tedious showed you I was subtracting 3x from both sides. That's all I was doing. Very slow and tedious, right? So that zeroes out. I have a square root of 3, and that's 2 of these sine of x's because I had 5 and negative 3 of them. I almost have the trig function isolated. I only want sine of x isolated, not the 2 times in front. Why do I get rid of a 2 times? I divide by 2. Now with this technique, I have it isolated. Now I've got it isolated all the way down to one trig function. Now I always at the end have to do, I'm just going to call it guess and check, but it's not. It's by knowing your unit circle. So I'm trying to find out what angle measurements, all of them, in which the sine of it will produce a square root of 3 over 2. Well, first off, it's positive. Is that in quadrant 1, 2, 3, 4? Where does that happen at? So I'm going to tell myself over here it's quadrant 1 and quadrant 2. So let me get all the solutions from quadrant 1 first. I'm going to scoot way over here. So what x values, so I'm just taking this out right here, what angle measurement, when I take the sine of it, will give me a square root of 3 over 2? Pi over 3. Plus every rotation forward and backwards. I've got half of them here. Obviously, they're not going to ask me to list them out because you can never list out all of them when there's an infinite number. I'm going to go to quadrant 2 and gather those because there's more. I'm going to put and here. Remember, that's my symbol for and. I have this is the answer and I need to get some more. In quadrant 2, what makes this true? Oops. So the x could equal 2 pi over 3 plus every rotation. Oops. That is my answer. X equals pi over 3 and every plus 2 pi. X equals 2 pi over 3 plus 2 pi.
That's it?
Yes, that gives me all of my solutions. Right? So let me show you that it's all of them. I'm going to let n equal 0. That gives me x equals pi over 3 when n is 0. When n equals 1, it'll give me x equals pi over 3 plus 2 pi. That is pi over 3 plus, I want a denominator of 3. That's 6 pi over 3. So that is 7 pi over 3. There's another one. There's another answer. When n equals 2, let's get us another answer. That's x equals pi over 3 plus 2 pi times 2. That's x equals pi over 3 plus 4 pi. That equals pi over 3 plus, want a denominator of 3. That's 12 pi over 3. That's equal to 13 pi over 3. There is another one. I can go on forever. See? But I'm going to keep it short because it wants all of them. And I've only done 3. And there's an infinite number. I could also continue. I could do n equals negative 1, n equals negative 2. I could do any integer I want. And it is a solution. I just had to know the one within one rotation. Within one rotation, this makes it true and this makes it true. And every rotation forward or backwards after that. Your turn. correct? Is there a question? Please ask it. Okie dokie. The thing that's changed is I don't want you to find every solution possible, only all the solutions within one rotation from 0 to 2 pi. You notice I included 0 but not 2 pi because 2 pi is 0. So it is one complete rotation. So now I want to find all of the possible x's that are in between 0 and 2 pi. All right. I'm still on the same technique, technique number 1. And that is isolate the trig function. Oh, it's already isolated. Fabulous. So now I'm just going to ask myself. Now, I'm sure a lot of you right now are really bugged because you don't like that too. Here, let me help you. Okay, now it's all gone. So, tangent, he's positive in what 2 quadrants? 1 and 3, right? So I'm going to write that over here to the side. Okay. So now I'm going to come over here. Quadrant 1 is the one I'm going to do first. I'm going to take that stuff, that entire angle, and say 2x is equal to square root of 3. I'm sorry. Let me try this again. Sorry. I'm already messing this up for you. 2x equals what? Okay, so I'm going to cover that back up again. It's just stuff, right? Just like last time, I put down the x. I don't care what that is. So what in quadrant 1 is tangent going to be square root of 3? Is that pi over 6 or pi over 3? Pi over 6? Luis, I got no. Is it pi over 6 or pi over 3? It's pi over 3. Right? When in doubt, sketch it out. Oh God, I didn't mean to say it that way. Tangent is this over this, which is this, which is this. Right? So I don't care what this says, right? I don't care. Okay? Then you told me it happens at where? At pi over 3 plus 2 pi n. Right? I did the same thing. I didn't freak out about that stuff. Right? I pretended it was an x, didn't I? I pretended it was an x. So I put my finger over so I didn't freak out. I said, oh, that's quadrant 1 and 3. I put my finger over it, and I said, where does that happen? At pi over 3 for quadrant 1, plus every rotation. Actually, tangent, doesn't it repeat itself? Its period is actually pi n, not 2 pi n. My mistake. I have to remember that. Tangent and cotangent repeat itself every pi. That's its period. Okay, I'm going to pick up my finger. Now I have to look at it, because what do you solve for? For x. Now that I've got an equation, I'm going to go solve for x. How do I isolate the x? I do what? Everything I divide by 2, don't I? And when I clean it up, doesn't it look like that? Okay, so I started out, this was isolated. If it wasn't isolated, it'd have a number out here or stuff underneath. It doesn't. I don't care about the angle. That didn't matter to me. But the tangent function is isolated. Then I covered it up so it didn't freak me out. I copied it. I still covered it up. I answered my question for quadrant 1, and I continued plus pi n because it repeats itself every pi. That's its period. But then I had to pick up my finger. I have a new equation. I'm supposed to be solving for x. So now I divide everything by 2. So now I'm supposed to be finding all of my solutions from 0 to 2 pi. So now I'm going to start with, I'm going to go and get them. I have to actually list them out this time. I'm going to let n equal 0 first. Right? Because if I started with a negative number, wouldn't this answer be negative? And that's not within my row notation. So I'm going to start with 0. That means this goes to 0. My first solution is pi over 6. Wait, let me make sure. Let me just plug it in to make sure. Pi over 6 goes in for x. So 2 pi over 6, which is pi over 3, tangent of pi over 3 is this. Yes, it is. Let's find the next one, if there is. I'm just going to keep counting up by 1. So x equals pi over 6 plus, and I put 1 in here, pi over 2. I need a common denominator. Oops. Right? Is that between 0 and 2 pi? Yes, that's 2 pi over 3. Yes. So I have one answer. I have a second angle. I got to keep going till I find them all. Pi over 6. Let's see, I'm using this one here, right? Right? This is the one I'm using. Now I'm going to put in 2 plus 2 times pi over 2, right? 2 times pi over 2. So I'm going to clean this up. Oops, plus pi. I'm going to make a common denominator right here. That's 6 over 6, right? So that's equal to 7 pi over 6. Is that within one rotation? Yes. So this is another solution, and I'm still not done. Oh, happy days. Let's see, this guy here, and I'm going to put in 3 plus 3 times pi over 2. X equals pi over 6 plus 3 pi over 2. I need to make, oops, 2. Common denominator, multiply both by a 3, top and bottom. I'm going to reduce that. Is that still between one rotation between 0 and 2 pi? Yes, it is. That is another solution. Lord help me. I'm tired. 4 times pi over 2. Let's see, that cleans up to a 2 pi, doesn't it? Yes? 2 pi plus pi over 6, isn't that beyond one rotation between 0 and 2 pi? So I'm going to stop. I get nothing from here. So from quadrant 1, I got 1, 2, 3, 4. Not done. Still got to do quadrant 2. I'm sorry, quadrant 3 for tangent. Settle your excitement down. Shh. I know you're really excited. Quadrant 3. I'm going to pick up this angle. Hide my little finger because I don't want it to freak me out. In quadrant 3, what angle measurement, don't worry about that, don't look at that. What angle measurement would give you square root of 3? What is it? Four pi over 3 plus pi over n. Now I'm going to lift up my finger and go, I'm supposed to be solving for x. I've got to divide by 2 on everything. If I did my math right? Got to multiply by 1 over 2. I canceled out a 2 and a 2. I get 2 pi over 3, right? There is what I'm going to be using to go find them all. N equals 0. X equals 2 pi over 3. When n is 0, that is gone. Next, n equals 1. That's x equals 2 pi over 3 plus pi over 2 times 1, which is pi over 2. I need to make a common denominator. What is my common denominator going to be? Class? 6. That's going to be 4 pi over 6 plus 3. No. Yes. I can do math today. It's questionable sometimes. 7 pi over 6. Is that still within one rotation? Yes. Oh, I've got a repetition though. Look at. Got a repetition. That's probably because it's tangent. It repeats itself every pi. I'm going to check. I'm going to do one more, make sure. X equals 2 pi over 3 plus 2 times pi over 2. Cancel. That's 2 pi over 3 plus pi. That's 5 pi over 3. It looks like they're on an all repeat because I'm in tangent. I wanted to check and make sure, so now I'm just going to stop. My solution set is, you must, proper math, you do them in order from smallest to largest. Let's see, these are it right here. I've already got you and I've already got you, so this is the only new one I got. So it's going to be pi over 6. Let's see. Oh, and this one has been repeated. There is nothing new under the sun. So 2 pi over 3, 7 pi over 6, 5 pi over 3. Those are the only 4 solutions. If I put them into x in the original problem and multiply by 2, I take the tangent of that and I will get the square root of 3 on all 4 of those solutions. If I would have simplified that, I could have stopped after 2 and see that it was repeating. Only tangent does it repeat. Sine and cosine it does not. Start working on this one. And in 30 seconds, I'll work right behind you. Technique number 1, isolate the trig function. Oh, it is. Where is it positive? What 2 quadrants? There could be repetition here too. Good. Then I take this guy, whatever he looks like, I don't care what he looks like, and I answer my question. It has to be pi over 4. For quadrant 3, what would it be? From here, you just put in n is 0, n is 1, n is 2, n is 3, and every answer you check and see if it's within here. Stop once you go on the outside, or stop for tangent on repetition and write out the single answers.
So we divide by 3?
Yes. Right. Yes. Sure.